we also have to look at how the body has deformed. Okay, remember this is a deformable body. Okay, so a body, if I take a body, the body might probably deform from, so let's say the same point P here would have deformed and moved, right? This is a different shape that it has taken while some forces are acting on that. Okay, we wish to find out what? We wish to find out how the body has deformed. That's the question we want to ask. Okay, and this question, I'm going to make it a very simple question. You can complicate to the extent possible, but we're going to make it very simple from whatever our understanding has been in terms of elongation in one dimension. Okay, what did we do in one dimension? Let's say I have here, let's say this is x direction. X direction, I have a string or one-dimensional body, and if it elongates by an extent, and let's say this length is L, this is delta L, then epsilon, which is strain, is given by the ratio of the extension divided by L. Right? This is what we did. Right? Since it is in the x direction, I can call this as epsilon x. Okay. So far, so good. Is this clear? Now, there are two things to it. One is the body is in the x direction. Is in the x direction. What do I mean by that? If I take a small portion of this, okay, which is, let's say, delta x, I take, okay, and this extends, all right. This extension divided by delta x will give me epsilon x. Okay, this is delta x. The elongation is also in the same direction. I'll repeat it once more. This body is a line in the x direction. The body is a line in the x direction, and it is elongating in the x direction, which means there are two x's I am using. One is the body, which is a line in the x direction. The other is the elongation that is along the x direction. And therefore, I should put it as epsilon x, which is the first one representing the line that I have taken in the body. And the next one is which direction the elongation has occurred. Or in other words, if I have a line that I have taken over here, which is dx, and I'm looking at the strain in the direction that is along this, then what am I looking at? I'm looking at epsilon xx. Is this clear to you? Very simple idea. This becomes powerful because if I need to have strain in any other direction, I have to do exactly the same thing. For example, how do I find out epsilon YY? What do I do to find out epsilon YY? Again, one more question. What do I do to find out epsilon YY? Having understood what is epsilon XX, how do I find out epsilon YY? This is the body that I have. Go on.
Sir, along Y we will take the.
Come again?
So, like along Y we will.
What do we take? Yeah, but before movement, I want you to locate it. There are two Y's here. There are two X's here. A wise person will look at two Y's here. What do the two Y's represent?
Sir, one is phase and the other is force, sir.
No, that is for stress. What did I do here? This will give you a clue.
So one is the length along y-axis and another is the elongation along the y-axis.
Exactly. See, I picked up a line element. I'm going to call this as line element. Okay, which is along the x direction, and noticed what was happening to that line element. Okay, so the line element was going like this. It had an extension. So this was dx, and it had an extension. Okay, right. That's what I did. Supposing I want to find out epsilon YY, what would I do? That's the question I'm asking. Go ahead, Chaitanya. I would pick up.
We would want to know the length along the y-axis.
Wait. I would, yeah, exactly, Karthik. I will consider a line segment along the y direction, infinitesimal line segment along the y direction. That's the first thing. So which means I have fixed this y. Then I ask the question, what would be its extension in the y direction, and or the ratio of it, okay, and therefore the next y direction. Clear, Chaitanya? All right. So if I do that, I'll be able to get epsilon YY. Okay. So in other words, if I have taken a rectangular box like this, extension that happens in this direction will be connected to epsilon XX. Extension that happens in the y direction like this is connected to epsilon YY. But there is also epsilon. If I have to extrapolate, there is also epsilon XY. What shall I do? What shall I do? Epsilon XY, what shall I do? So for that, I'm just going to show you. So what I've done here is I've taken an arbitrary body. Okay. So just for your visual effect, I'm going to do this. Give me a second. No? I now have an arbitrary body. Arbitrary body. Are you able to see? Okay, I have drawn the line elements. Okay, let's say this is the x direction, this is the y direction. Okay, so as it deforms, you can see all those squares are there, but they have become rectangles, right? But they have also sort of instead of rectangles, they have now become parallelograms, right? Parallelograms, right? And that's what I have to describe. This is a more general deformation that I can see, correct? Right? I want to represent this, and let's say each of these squares represent a point. Okay, you can think of since you are able to see, it's fine, but you can think of each of those squares to be, or square or rectangle to be, nothing but representing a point. Okay, or you can do one thing, which is you can take the lines in the in the x direction. Okay, I can do this in the x direction and y direction. Okay, and ask the question, how are the line elements stretching is one question. The other is, while it was perpendicular initially, right? It was perpendicular initially, right? After deformation, they seem to have lost the perpendicularity, correct? And this concerned the tendency of what was y to be moving in the x direction, what was x to be moving in the y direction. So far, so good. Is this clear? So, if I ask the question, what is epsilon xy? What is epsilon xy? Then I'll say this is the line element, and this is the movement in the y direction. For example, if this is the line element I have picked up, which is along the y direction, let us say it has moved like a parallelogram to this, right? This movement has to do with epsilon xy. Is it epsilon xy? Epsilon yx. Fantastic. So this is epsilon xy. Epsilon yx has to be like this, correct? So that if I do like this is the x element that I've taken. This x element is now, let's say, rotated like this. Okay, and this movement is related to epsilon xy, and this is related to epsilon yx. Okay, right. So I have now taken the elongation in this direction, elongation in this direction, also change in the angle between them. So initially it was pi by 2. Now it has shifted. Okay, so this is one angle, this is another angle, right? The total angle that has changed is, I'm going to call this as some gamma xy. As you can see here, gamma xy is nothing but the addition of these two. Okay, so I'm not going to call it as epsilon xy and epsilon yx here. The reason is the following. I want you to be very notice very carefully. Okay, just notice this carefully. I started with a body which was rectangle. Now it has become like this. Now it has become like this, right? This is one angle that I have. This is the other angle I have, right? Initially it was perpendicular like this. Now it has changed in angle. I can always rotate this fellow and make it into something that is like this. Can I not? I take this diagonal, I rotate it, so this coincides with the x-axis. Now what do I have? I have this total angle, right? I can do the similar way by rotating. And rotation is a rigid body motion, correct? It does not have any deformation, right? Agree with me on this? And therefore, I don't want to distinguish between this and this. I'll put them together and call it as gamma xy. So the angle that has happened, this total angle change is gamma xy. Either you want to align it with x or y, it does not matter. Because that's just a rigid body rotation. I'll just ignore that. So far, okay? Is this clear? In that sense, I will say this is equal to epsilon yx is equal to gamma xy by 2. I'm just equally dividing between the two. If this idea is clear, you learned something on strains today. If you have a question, you have to ask me now. Thanks, Kishore, for identifying. If you have a question, you have to ask me. And therefore, let me erase this. And therefore, now it's becoming clear to me. I can now write a matrix with all this. This is for the element. So element X. So this is element, line element. Okay. I can take line element X. I can take line element Y. Right. I can take movement in X direction. Movement. Shall I say stretch so that it's clear? Change. Okay. I'll use change. Okay. Change in X direction. Change in Y direction. And say, okay, if I have X element taken and there's an elongation in X direction, then I'll call it as epsilon XX. Similarly, y element y change as epsilon YY. And if there is an x with a change here, I'm going to now change it to gamma xy by 2, gamma xy by 2. Okay. Or I can write this to be epsilon XX, epsilon XY, epsilon XY, epsilon YY with epsilon XY equal to epsilon YX. Remember, I have enforced a symmetry over here. Okay. This is the way I can define the strain in the two-dimensional body. Okay. And remember, this is pertaining to a point P, and this point P I can blow up. It seems to have one length this way and another length this way. Okay, so I can take this line element for considering this line element for considering this. Okay, so I've just done this. You can see it now. This is this. Think of it like this. I have a reference frame for which the body now initially has a perpendicular line elements dx and dy. Okay, after deformation, this has stretched, and this has stretched, not only stretched, but also the angle has changed. Okay, with this, now I can do many things, but right now I will consider primarily that I have these strains available now. Got it? All right. Now this is nothing but the strain of point P, correct? So this is the strain of point P. Along what directions? X and Y. Okay, so I'll put P inside so that, okay, and this is nothing but epsilon XX. So I can now write this to be epsilon IJ, where I is X or Y, J is X or Y. Okay, this is in a matrix form. Okay. Now you can ask the question, okay, what if it is a line element that I've taken along this and along this, which is X prime and Y prime? What would be your answer? What if I take along X prime and Y prime as line elements? So basically, I've now taken a line element that is like this and like this. I will get what? Epsilon X prime, epsilon Y prime, tau, I'm sorry, gamma X prime, Y prime, correct? Right? Without much thinking, it's now clear to you that I can transform. So this is with respect to xy, right? I can also transform and write the same strain about x prime y prime to be nothing but epsilon I prime j prime matrix. Is this clear to you? It's the same strain, but with respect to x prime y prime. This is with respect to xy, and this is with respect to x prime y prime. And if x prime y prime are and x are related, then just like what I have done for stresses, I should be able to transform these. So what shall I call this quantity as a tensor? Fantastic. So now we have recognized one more tensor, which is a strain tensor. So today what we learned is a strain tensor. Okay, this is pertaining to point P.